Hey,
You could probably say something to be like, we could go out to Biltmore again.
Gentlemen, we're
There you
live. Boy, have we been live from our living rooms and man caves. It is the SBAU Astro Hour. Welcome aboard, everybody. It's all coming in from the Santa Barbara Astronomical Unit, which is based at our beautiful Santa Barbara Museum of Natural History. I am your host, Ronnie Heron. On behalf of my distinguished friends on the screen of Zoom, all around me, whom I'll introduce in a moment, Astro Hour is dedicated to astronomy education, particularly the breaking new discoveries and theories of astrophysics, and that are happening almost every day. 5 years now, we've been doing this, updating our public and our members with cutting edge cosmology. And this will be episode 274, ladies and gentlemen, for the end of the month of May, the 25th, which is Memorial Day, one of the earliest, to the 31st. And we're on YouTube with our own channel. Start with this program, then check out our website, sbau.org, and then come to one of our meetings. Second Saturday, Star Party outdoors at the museum, or the first Friday of the month open general meeting at the museum 7 to 9. Here are this week's topics. We got it down, man. Going to check out our neighbors, the other planets, starting with Mercury, going out. We'll report on lunar libration this week, the nodding motion caused by the tilt of the moon's orbit around the Earth, something some of us weren't really aware of. A new image from the ESO's VLT of a cloud of gas orbiting, you ready? Our galaxy's central supermassive black hole. That's got to be a hell of a accretion. Just NASA's Psyche continues out past Mars, which incidentally gave it a 1,000-mile-per-hour push on its way to the asteroids. We're getting more still from the New Horizon Pluto probe, the what's the word? The dwarf planet may have a subsurface ocean. Let's meet
go.
the
Yeah, that's
guys,
weird, huh?
man. What did you say, Mr. President?
No, it was me. I just said that ocean is very interesting.
Well, you and I are going to have stuff to talk about. I'm fascinated by the oceans under surface, whether they could possibly harbor life. Let's meet the president, Jerry Wilson, who is Professor Jerry. Good morning, sir.
good
Thank you.
morning. Good morning to Joyce, and good morning to my grandkids. Here's Grandpa,
Oh,
I see the
uh,
kitty in the background.
Calvin, and Riley. Yes, we're remodeling our upstairs, and so I've got a lot of junk in my office here out of the way. And one of them, my cat, usually spends time back here when I'm doing this. And
Yeah.
here you can see her.
I
She's
see
not
that
very
cat.
active right now.
Well, she does like Chuck's cat. It'll walk in front of you in a minute.
Yeah.
Speaking of that, here is the outreach guy in front of the flag of Ukraine, Mr. Chuck McPartland, who's also married to a Pat. You forgot to say hi to Pat, your wife, or introduce her, but she's the first lady, Jerry, of the club. How's Pat McPartland doing?
Doing fine.
Okay. And you want to really quickly encapsulate what's coming up next, Westmont, or did we do Westmont Friday?
Westmont has been done. There's really nothing public left for the month of May.
Okay, we got our big potluck scheduled for the 12th. And we got on the screen who's married to Karen Kim Crawford, lens expert and Sunday morning star of the museum's Palmer Telescope. 208 people lined up yesterday, huh, to see the sun.
Yes, a lot.
And we almost lost you to the front yard. We'd like to thank Karen for getting you inside.
Yeah.
Tom Whittemore, who edits our newsletter and used to hold court in his own Westmont lab, is not with us today. He's got an airport run to make. But we got lots to talk about. We start with our sillies, though. These are silly science cartoons. I don't know about you guys, but I got 9 forward to me by Professor Wilson, who comes up with incredible lists every week of talking points. And we get into most of it. Sometimes we carry over. Let's go to those 9 sillies, shall we? These are scientifically based, and it's going to take a little while at the control
Well,
channel.
I don't know. I don't know if I saw these. This would be.
Did you see this one?
We're not seeing anything
Nothing
right
on,
now.
Jerry.
Oh, you're not getting anything?
Mm-mm.
Okay.
Here we go.
There we're
Hold on.
Yeah, there we go.
okay.
We're seeing your entire desktop.
Oh,
Couple aliens checking out a captured Earthling.
okay. Just a minute.
Yeah.
Maybe
Is
you
this a new
sent too many.
computer?
You usually send us 5 or 6. We got 9 this time. And
Aha.
Tim Crawford, incidentally. I don't know if I said your name.
Yeah, you
Oh, I
did.
did? Okay. There they are. Oh, this has got to be from the archives of President Trump's Defense Department. Are they finally releasing these pictures like this? Jerry, tell us what's going on there.
Oh, these two aliens are got a human on the gurney and they're saying, wait, these orders are for a yearly reconnaissance. We're supposed to be doing an annual probe.
Not on, take out the U, never mind.
Yeah.
One of the ends of the U. Okay, can you explain this, Chuck? Are we on a Mars? We're on the Mars planet, right? With the Chinese.
This is 2 bases on Mars, one for the U.S. and one for China, and the U.S. astronaut is pranking the Chinese astronaut.
Oh, God, I didn't see the American one in the
Yeah,
background.
yeah.
I'll be damned, Chinese.
Yeah, I
Okay.
didn't see these. I'll be darned. I didn't
So
get
it's a little green man. Okay, here is let's see, who's talking to who? You want to figure this one out, Tim?
Sure, I'll try it.
It's very
I'm
simple.
I may it looks like the Earth is talking to the moon, I think.
Yeah.
The moon talking to the Earth. If you read
Moon
from the
talking to
top.
the Earth said, I made something for you. Whoa, what's this? I know it's not like the usual rainbows. It's a moonbow. Only you can see it.
Really?
Aha. Aha.
Like a
We
ring
talked
around the
about
moon.
those, have we not? We talked about moon bows.
I think
Yes.
we did.
Is it like zodiac light?
No, it's an
No.
Earth phenomenon.
Yeah, purely
Isn't it
astronomical.
moisture in the atmosphere?
Yeah.
Yeah.
All right, this looks like a bunch of down and out clone scientists meeting at one of the local cafes. Jerry, what's this all about?
This is a cafe and they're all full of people with the very same face. And it says, Professor McEwen, long time no see. How's the cloning research coming?
Oh man,
So they're all
everybody's going, where's Waldo? He's everywhere.
so the restaurant is Bunny's Pie Repair. There's a piece of pie.
Oh, there it is.
This guy's got an arrow in his back.
Arrow.
There's an eyeball there.
There's the O2 and the K2.
I don't
Oh,
see. I see
wow.
a K2 up there.
Yeah, and the O2 is on this guy's hat with the arrow in the
Oh yeah.
foreground.
Oh, that's right. Yeah.
There's the
And up in
upside
the
down
left-hand
bird.
corner, another eye.
Oh yeah, there's the upside down bird.
And
Oh,
then the far upper left corner is the little spacecraft with the eyeball.
Yeah,
an
that's
eyeball,
right,
yeah.
Okay.
Well, this cartoonist
What's
loves
the
to
upper
give-
right? Is that a bunny? Oh no, that's just a picture of the sign.
No, well, that's across the street is Bunny's Pie Repair, but he has an angry bunny, or at least a
Oh.
bunny making a face in most of his cartoons.
Oh, okay. Yeah, I love these. I really like these.
There's also a pipe. You can see the pipe in this one, and in the previous one, there's a pipe hanging off the coat rack.
Oh,
Oh,
okay.
yeah, right there.
a pipe.
Yeah.
Yeah, right there.
Why a pipe? Okay. Well, how
Oh,
often
there's-
does your pie need? How often does your pie need to be repaired? I've wondered about that one. All right, this next one you went to, if you'll go back to it, the new one is, it looks like a mafiosi sitting next to a hitman.
Yeah.
Chuck, you want to read that to us? What's his name?
It's silly.
He's saying the stars
Godfather.
make me feel so small and insignificant. Put out a contract on them.
So there's the pipe. There's the pie, and there's the spaceman. And I don't see anything else.
None of the other regulars are in there. I was looking in the star patterns, but there isn't anything.
Okay.
Well, this is the guy, huh? Okay.
Yeah, this is neat stuff.
You'll
Like
like this one. This would be given to Whittemore if he were here. He's the pun guy.
Yeah.
But Tim, why don't you go through this?
Sure.
Two gentlemen.
Eye doctor? What a coincidence. What a coincidence. I doctor too.
So there's the eyeball.
Yeah,
Yeah.
just the eyeball in this one.
Yeah.
All
Yep.
right.
You'd think he'd have a K2 in the chart, but he
In the
didn't.
chart, right, right. And then that little thing in his hand may be something, but
What? That's for looking in your ear, I think.
That's a little light source.
Yeah.
This is the same cartoonist.
Yeah.
Okay. I've
Okay.
discovered an inhabitable planet covered with rolling grasslands, and the automatic AI controlled lawnmower is going, oh no.
I
Oh, it's a
didn't get that.
lawnmower. Okay, this is a good one. A large pizza with everything. Here it is. All you got to do is lay it on the ground and upside down, and doggone if the whole earth isn't on that pizza.
Yeah.
You know, last week it was a hat. Remember with my hat?
Yeah, it was a whole earth hat.
I assume that's pizza dough, that big round thing. It's not a rock.
Well,
Okay,
this thing, I
take
think
that.
it's the eyeball.
Yeah, there's the eyeball and there's the space eyeball.
Yeah.
The flat
I'll
earth.
see the rest.
If it were flat earthers, they'd have the whole pizza being the earth. Okay, Chuck.
Okay, well, you got R2D2 and
C3PO.
C3PO. C3PO is having dinner, I guess, and he's going canned ravioli again, and it's Chef Boy R2D2.
Boyardee, is that what it used to be
Yeah.
called?
There's an eyeball, and there was a
Go to.
pie. There's a piece
Yeah.
of pie and an eyeball.
Lord, those are all Bizarro guys. Is that
Yeah,
what it-
I absolutely love those. They're just
And
great.
he puts a pie and a pipe. and
Yeah, he
everything.
scatters pies and pipes and little flying saucers and things in them.
Okay, here we go. The night sky.
It's getting low. It's getting low.
So
Mm.
this is not a photograph because I had it several days ago, but it's a planetarium software, the sky something or other, and it's tonight, May 25th at dusk, just after sunset, and you see Mercury, Venus, and Jupiter lined up, as all the planets are always lined up every night. And the next time this stuff will occur will be tomorrow night.
Yeah.
They are lined up on the ecliptic.
After midnight.
After like, well, 24 hours. Okay. Anyway, you have to have a very good horizon to be able to see Mercury at this time.
Yeah, Tom Whittemore will get it.
Yeah.
So down in Australia, they see the same thing, only upside down.
Yeah.
And
Wow.
Jupiter's getting low, man. We're going to lose it pretty soon.
Mhm.
Yep.
Will Saturn come up again?
Yeah, later in the year.
Uh,
We'll have Venus for a long time, but it'll be low for a long time.
yeah.
Okay,
this
crescent
is
moon.
Oh,
This
I have a
is-
question on this one.
okay, go ahead.
No, I'll wait till you do it, Jerry. This is interesting. The age of it is what I'm interested in.
Okay.
What is Endymion?
Endymion.
Endymion. It's a
So
crater.
this is Endymion. This is a crater on the moon. This was taken last week, May 19, when the moon was a waxing crescent shortly after being new moon. But the moon tips, it tips on its axis as we see it, and the moon rotates through things that are near its edge like this. Later, a couple of weeks later, we'll be down here with a lot more clearance to the edge, so they'll be easier to see and less foreshortened. And that's the case of this one for, oh wait,
This is the view we had at Telescope Tuesday out at the big box.
okay.
Okay.
Is this called libration? Is this what we're doing?
Yes.
Yeah.
Oh, you did have a Telescope Tuesday.
Yeah.
Oh shoot, David was saying that there wasn't one. Maybe he was referring to this week. Okay.
Yeah, he was there.
Okay.
And Tessa and Edgar.
Wow.
I've locked myself out of the control panels. Don't panic, it's not bad.
The cat's up behind you.
So this is tonight. A week later, May 26th, tomorrow night. And you see Enderman here is way away from the edge. It's not way over here like now, it's tipped. So it's inward and you can see it more directly. So let me see if I can do this without knocking myself off the air.
Uh-oh.
So before Tim asks his question, I'll throw in mine. Libration is a form of wobble.
Yeah, wobble.
It looks like a wobble to us. It's because the moon's orbit is elliptical and its axis is tilted relative to us.
And yet if it wobbles, it still manages to stay totally tidally locked.
It's not really wobbling. It's just that it's in its orbit. It comes closer to us and farther away. So it lets us peer around the edges.
Oh, okay, gotcha.
Moves faster or moves slower.
Yeah.
So we probably see what, 54, 55% of the moon.
About 60%.
60.
Yeah.
It's funny that when it was way over at the edge, it appeared to be kind of an oval and elongated. And then as it got to this where Jerry's going to go with the next picture, it becomes a little bit more circular.
Yeah.
It's just an illusion of the angle that you're looking at it.
Yeah. Perspective.
Oh, look at that.
Oh. Well, this is the reason you had trouble, Jerry. It's moving
Whoa.
the video.
Yeah, suppose you're standing on the moon and you're trying to keep your balance. Now, this is an illusion. When we really do this, it's appearance from the Earth as it goes around us.
Huh.
Oh yeah, that little subtle movement.
Yeah. See, in this thing over here, there's a small Maria.
Grimaldi.
Yeah, Grimaldi. See, it's right on the edge, and then it moves in away from the edge before it disappears. And
on the other edge, it really becomes apparent when it moves kind of sideways.
Yeah. Yeah. So this is how they can take pictures of the around the rim a little bit. You can get as I heard the numbers mentioned a minute ago, you can get 60% of the moon if you are very patient and take lots of pictures.
Well, apparently they're looking at South Pole for future colonization. Does that come and go in and out of sight?
Parts of it, yes.
Does it?
The South Pole is down here.
Yeah, right. And no North Pole? We don't have the same stuff going on up there with possible ice?
No, the South Pole is all mountain ranges and heavily cratered. So it's got some regions where there's a down inside that's always shady. The northern region does not have those deep craters, but the radar indication that spots hydrogen oxide indicates that there may be water up there too. There may be water at different sites away from the South Pole.
Oh. But now China wants the far side that we don't see. Are they aiming for North or South Pole far side?
Everybody's aiming for the South Pole.
Where did Jerry go? Just kidding, Jerry.
Oh.
And lava tubes. Can you see a lava tube? Is that possible? Are there any photographs?
Oh, yes, we've seen lava tubes from orbit, not from the Earth, because they're you can indicate where they are, but you can't really see down in them like you can from orbit.
Is it obvious? Do they look like tunnels, like caves?
They look like holes that you can see the bottom of.
Now, my question on that crater, Jerry, before you leave, was that they estimated the age of that crater to be 3.8 billion years.
Yeah.
How did they do that?
They look at overlapping craters and cratering rates, and also at the rocks brought back by Apollo. That gives you sort of a baseline for when the big basin formed. Not the big, not the South Pole Aitken Basin, but Imbrium, I think, is the basin that they use to base a lot of the
Oh,
dating on.
There
Huh.
are also what they call two major cratering eras, two bombardment eras. One early on and one not so early on, and that's where
Okay.
most of the moon's craters came from.
Huh.
Those those events.
Interesting. I never knew that and really wondered.
Uh-huh.
I was thinking if they stuck some kind of thermometer in the moon.
So can you see this?
Yes.
Yeah. Yes.
Okay, good. We're going to take a look at the Milky Way core where Sagittarius A is. And it is right, there's the famous teapot
Yep.
asteroid. So this is the teapot's top. This is the teapot's spout. And right off here, this is region up here is where the core of our galaxy is. This is not missing galaxy part. This is dense dust clouds that you can't normally see through, but infrared long wave electromagnetic radiation can get through this. So the way to look through here a bit is through the infrared and also from radio waves out here.
Mhm.
And that's what I looked for this week.
Oh, wow.
This is a picture of that region of the Milky Way. There's right in the middle of this region. And then these are three major dust clouds. It's a good description in the caption for this picture. And that is, oh no, I left it's on the text of this picture. So this is from a very low, oh no, we're getting to that. Oops. Wait a minute, I touched the wrong thing. Again, okay. Yeah, these are, the one I showed first is from the Sky 6, it's a planetarium program. This is a picture of the star clouds from the European Southern Observatory, taken in the infrared. This shows clouds that you don't normally see in the visible here in this region.
I'll
And
be right
about
back.
here is the center of the Milky Way.
That's where Sagittarius A is.
Now, this is from the Spitzer Space Telescope. This is a infrared view, and it's looking at this long thing here. See, it curves down, and there's something going up here. And here, this is it. It curves down, and there's stuff going up here. So this is roughly an infrared view. It will look different because things look different from the visible to the infrared. So this is the infrared view of it. And the core of the galaxy is right in this region, I believe. And the next one is a combination of Hubble and Spitzer of this core region. They've combined their reference to, what's that?
Can I throw in a quick question since
Go ahead.
you're talking infrared here? Why not aim the James Webb at it? Too bright?
Yeah, we
I thought it said it was a combination of the
this
web.
is a combination of Hubble and Spitzer, so it's
Oh,
visible
okay.
infrared. Spitzer Space Telescope was the first long wavelength telescope to go up. The James Webb goes much farther into the infrared and would give similar views. I didn't come across one of those. but this one is good enough. So this shows clouds of glowing gas and dust that mark as well as 3 large star clusters are visible. So 1, 2, see, I'll read the text. Magnetic, the upper left near this one, I think this is the other one. This is the Archer cluster.
Oh, you're right. That's it. Yeah.
And then,
Then that lower left and then the right.
yeah, and the quintuplet cluster in the lower left. And the massive central structure around A star, Sagittarius A star, is visible on the lower right. So this is where the center of the galaxy is, around in this cluster. And
Oh, okay.
the
Okay.
reason for this is that the Very Large Telescope, which is a radio telescope array in Chile, that is took a picture of this, which cut through all the gas and dust. And this is the star cluster that's around our central Sagittarius A star, which is in the center of this cluster. And the gas and dust and all the interesting stuff from the previous picture is not here because we're looking now at radio waves well beyond where the James Webb Space Telescope.
So Jerry, Sagittarius A is within that reddish region. And I thought it was above, but it's not.
It's in the kind of empty region right in the middle.
Yeah, that's my impression.
Oh,
Find any article that commits to that has an arrow and commits to here's where it is. So I've narrowed it in and researched it as much as I can, but I believe that with Chuck that it's centered in this region here from the text I've read.
oh, okay. Interesting.
So it's in the center of its own little star cluster, the stars of which are going like crazy around it, I imagine.
They are if you saw the famous picture, a 12-year-long video taken by Andrea Getz, earned her the Nobel Prize for astrophysics. She's from UCLA, my alma mater. And when her over 12 years, you can see these stars moving around Sagittarius A.
But it's a much smaller region. It's not all these that you see here with the gas.
Oh, that's right. Her picture is in here. So
I didn't realize you were a UCLA guy.
yeah.
Have you ever heard Ken Kellstrom's his speech on the different the different colleges? It's hilarious.
Oh,
The blue, I think blue and gold and Stanford, and I can't remember the other one, but it's
yeah.
hilarious.
Ken is from Stanford.
Yeah, and he was he has a bunch of jokes on it. So
Yeah, he and I were working in superconductivity in our graduate work.
oh,
And
wow.
there was a group of people that was called the superconducting mafia. In 87, when longer, higher temperature superconductivity in the ceramics was discovered, Hughes Aircraft Company in the form of Santa Barbara Research Center wanted to examine it and see if there was any possible use for our cameras with the speed of the superconductors or their sensitivity to infrared light.
Huh.
And we hired Ken Killstrom as a consultant. And he and I worked together for about 3 years together.
Oh, neat.
Yeah, sharp guy.
As the booker of the speakers, I have a quick question as long as you're on this topic. USC, I cannot get any reply from. Do they not really have a lot of astronomy going on at the University of Southern California?
No, when you don't get good responses from people, that's the individual person. It has nothing to do with the actual institute and stuff.
Well,
some people are quite pretentious and they don't want to do public talks. Some people
it's a matter of
and they're
how
very
often.
eager to do it.
Yeah, I've sent many
They're
exploratory emails.
probably just normal scientists that are very, very busy.
But USC isn't part of a Cal State or a U or a
No,
UC.
it's a private school.
Oh, it's
Yeah.
a private school.
Yeah, yeah.
Kind of
Stanford is a private
like
school also.
Pepperdine is.
Pepperdine is a private school.
Yeah, that's
The Claremont colleges with Harvey Mudd and stuff, they're private schools.
maybe that's part of the reason I don't get any response from them.
Could be. The public schools, they have in their charter usually that you have to make science available to the public in some form or another.
Oh,
And many of the individuals like to give public talks and some don't.
got it.
Now, this in Chile is the ALMA, the very large telescope.
Atacama Large Millimeter Array.
Yeah, this is, yeah.
This one was really, it was far out. When I first looked at this, I just thought it was a bunch of penguins.
I thought it was those four square-looking telescope observatories on the hilltop.
That's the VLT. That's the Very Large Telescope.
Yeah. And both of
Yeah,
these
those.
institutes are participated in contributing to the photographs that we just saw.
Oh,
okay.
These are the infrared ones from the ground. There was the infrared satellite from space, and then there was the radio telescope that we saw that got the cluster in the middle.
Got it.
And it turns out here there's a little note about the VLT is that it is one of the most productive facilities for astronomy, second only to the Hubble Space Telescope in terms of the number of scientific papers produced from facilities operating at visible wavelengths. So this is very, very active.
Wow.
can I ask when we look inside the four large scopes, are we seeing segmented mirrors or are we seeing lights inside or what is
They have louvers in there to let airflow come through to stabilize the temperature.
Uh-huh.
That's what you're looking through, those louvers.
Inside.
Oh.
But they all four focus on the same thing at the same time, just like radio television.
They can. They're all connected with optical cables so that they can act as an interferometer and combine their light. And these smaller ones do that too. 1, 2, 3, 4, 5. I think out. That's not one.
I think there's one off to the
Yeah, there's one's missing up down here.
Okay.
And see, these are on rails. They move. They can move and change their position on these different rail systems and change. When you get a big distance between two of these things, that increases their resolution because it acts like a single mirror with this resolution. And the bigger this distance is, the higher the resolution. But it has the same low light gathering power. So it's not exactly like a giant telescope of that size, of that light gathering power. These ones are fixed in position, but they can also sum their signals to make an interferometer pattern.
Wow.
So this has been operating since 1990 something, I think. Anyway.
Are we seeing something inside those black holes that are open, or are those computer screens on a wall or something?
Those are the louvers to make the temperature even. They can open it up to let the air come through to even out the temperature.
Yeah.
Oh, I see.
Now, if you've been in, I once took a VIP tour of the, like I'm a VIP, but anyway, I paid for the tour. And so from Sky and Telescope magazine, and Stephen O'Meara led the tour. He was the docent. So we went inside the Subaru telescope mirror dome and the Keck telescopes and the twin, I forget the name of them, but there's a north and a south one. All those domes, when we went inside, they were all refrigerated. They were closed during the day, and you had to have a parka and gloves and everything on because it was around freezing or below inside the dome. They were getting it ready for what the temperature was going to be like at 14,000 feet at 3 o'clock in the morning.
When they opened it.
They would open them up as soon as the temperature got, the sky got dark and the temperature got low enough to start observation. But during the daytime, they kept everything closed and they were chilling it, getting it ready, because they had segmented mirrors. And in the case of the Subaru, they had a great big 8 meter wide telescope in it. And it would take a long time for that thing to come to thermal equilibrium.
Oh, interesting. Wow. Not a
You
not a
told
place to
me,
go get warm.
I've learned here that everything's gone into little warm offices off to the left with computer screens. The
Yes,
days looking through a lens on one of these.
that's where the grad students are that are on site in those big telescopes. But the professors and the visiting scientists in Hawaii, they're down in a hotel at Hilo. They're in the control room at Hilo. But the grad students are up on the mountaintop in the cold.
Oh God.
But it does get
Doesn't
cold
help to
down
be a grad student.
It's a stage you go through.
God.
It's called chief cook and bottle washer.
And popsicle.
Yeah.
Well, how close to the equator do you suppose the Atacama Desert is? It's right there, isn't it?
It's below
No.
the equator. It's about as far below the equator as we are above it.
Oh, is that right? That far
Yeah.
down, Chile, huh?
It's not, yeah. And these things are above the Atacama Desert. They're up on 14,000, 15,000 feet altitude.
Wow.
The air
Yeah.
is thin. If you want to see, there's one telescope in Chile that has a very big dorm for visiting scientists and stuff. And they filmed one of the James Bond movies in that dorm. It looks like they destroyed the building, but that's all special effects.
Yeah.
But if you want to see what it's like inside, go watch that movie.
Quantum of Solace.
Oh, I was
Yeah,
gonna take a look at that last night.
Okay.
Well, I've heard that up in Ecuador, which is north of there, and on the equator, there's snow on a mountain or two.
Yeah. At high altitude, yes. Yes.
Yeah, wow. Fascinating.
Okay. Now we're going to visit our friend. We showed a very early release picture last week of Mars, taken by the
Psyche?
Psyche probe, yeah, going on its way to visit its namesake, Psyche. And as Ronnie pointed out or read in the intro, by going by Mars like this, it added 1,000 kilometers per hour, was it, or miles per hour?
Miles per hour.
1,000 miles per hour to the speed that it's approaching Psyche now. So it got a gravitational boost. But as it went by, they used all the cameras to take pictures of Mars, and we're going to see a bunch of those pictures. Now, this one is like the one we saw last week, but it's much heavily more processed, shows a lot more detail, and it shows a piece of the planet's crescent up here. And so this is a normal crescent if it had no atmosphere, but you can still see a bit of atmosphere refracting light up here. And these things go farther up than if they had no atmosphere.
That's Mars, huh? Wow.
This is Mars. Now, this is Mars. It didn't say which polar. The South Pole.
South,
This
I
is the
think, yeah.
planet. Yeah, South Polar region. And and then there's a closer look at the South Polar region here.
Yeah, that's something else.
Yeah, this is now these polar regions are combinations of water ice and CO2 ice. So as the seasons change on Mars, because Mars has about the same tilt as the Earth does, so it gets seasons like we do, but it doesn't have much of an atmosphere. But it has summer and winter, but the temperature usually is way below anything on Earth. So the CO2 in the winter, the CO2 makes the polar ice cap on that side of Mars grow gigantic, and the other ones shrink, but they never get less than the water ice. The water ice does not sublime away like the CO2 ice does.
Dry ice.
And there's an additional little bright spot there I wonder if that's that crater they often show that's got the ice at the bottom.
Oh, interesting. Yeah.
Yeah. Yeah, I didn't think of that.
It's a pixel.
Yeah.
Okay. So
Well, there's
now
water ice.
what's that?
Can water ice live pretty much or exist with dry ice?
Yes and no. Oh yeah, yeah, they're fine. If the temperature gets low enough, the water ice will even sublime too, but it usually doesn't get that low. The CO2 ice, I said that backwards. The CO2 ice it sublimes at very low temperature. So the Mars surface can get above the CO2 sublimation temperature, and then the polar ice cap largely disappears. But the water ice stays there because it's still way below the 0 degrees centigrade that water ice needs to interact. But
And
you
when
can,
the
you
Go
can
ahead.
use the
and when the CO2 in the caps sublimates into the atmosphere, it puffs up the atmosphere of Mars, and you get those winds that cause the dust storms.
yeah.
Oh, wow. That's
Kind
how
of
it works.
I have a chemistry-based question, or it's sort of like that. We never see carbon in a liquid form, do we? It goes from gas to solid or solid to gas.
You can make it if you want.
You can make liquid carbon dioxide.
Oh, yes, yes. You have to have it under high pressure.
Really?
You can make it in the laboratory.
Yeah, it's a pressure and temperature thing.
Yeah.
But when it evaporates, it goes from solid to gas.
At surface temperature, at surface pressure.
Okay.
But if you pressurize it, you can keep it in a liquid state.
There's pressure. Okay. Another common part of another.
Okay, my computer has frozen up with me, so talk among yourselves. I'm gonna come back on.
Talk among ourselves.
Chuck, do you really think that might be a crater there? That little tiny?
There is a picture of a crater with ice in it,
Yeah.
water ice in it, that I've seen several times. I just, to me, it's like, okay, there's a nice little white spot and it's roughly round. That might be it.
And it would be huge if we were down on the surface. That'd be really, really big.
Yeah, yeah.
What do you suppose the black blotch is, or the dark blotch?
Yeah. Yeah. I was
That's
wondering.
That's a non-sandy area, like a rocky area.
Oh, I see.
Mars is so interesting, but you know what? I don't know if they're ever going to get. If they might be able to do remote kind of JPL stuff, but I don't know about sending humans there. It just doesn't.
Well, if you're sending them there with our level of technology now, you're sending them there to die.
Yeah, yeah, yeah. It's not gonna happen. They're just
We might be able to do a quick visit there and back, but you're not going to live there.
Yeah. No, no. I think it was Heinlein that did he did a book called what was the name of that? God, I'm blanking on the name, but it was all about a guy that lived on Mars and then came to Earth and almost died because of the difference in the gravity and everything. And then went back. And all that is just baloney. That would just never happen. I mean, people would atrophy so bad. You'd have to be doing exercises all day long.
Well, it's not as bad as being up in the ISS.
Yeah, yeah.
You'd at least have 1/3 gravity, roughly.
Was it the movie Total Recall that
I got a comment I have a comment for Jerry from the live chat. and someone says the club needs a spring for a new computer for Jerry. But I think it's his program that does it, because he switches between programs.
Well, it's Microsoft.
Yeah, yeah. But yeah, I've often wondered if he couldn't put the show in a different format and so it wouldn't ever freeze on him like it does, because boy, it really, I mean, to do this on a weekly
and
basis.
one of them just really blows out the highs and the lows on the graphics.
Exactly.
You'll put up a picture and you'll see it good for a fraction of a second, and then blam, it goes.
And then blam, it gets
Yeah.
blasted. Yeah, yeah. And I always wondered what he was using, what program he's using, and if he couldn't switch to another type of program that wouldn't do that.
I always, when he sends out the notes, I open them up, and then I produce a PDF from it, and then I open up the PDF. He might want to try that. That seems to be a lot more stable.
Yeah, yeah. Maybe we can maybe, yeah. You know what? Maybe we can ask him to do that, and that might be a good way to go. Um, what's the other thing I was?
Well, let me throw mine in real quick. The club owns 2 or 3. There's Jerry. No, that's not Jerry.
That's Jerry.
That is Jerry. He's in the middle of a star field.
Yes.
You've
Okay,
gone
let me-
strange on us. Oh my God.
He's coming back from another dimension.
He's
Yeah,
an ET.
beaming in.
Well, I was about to ask if we have 2 or 3 separate, whatever they're called. Is it like an email address when you own a Zoom, whatever it's called? We're on a Zoom thing now, but it's a different one than we're on for the planning meeting.
Yes, you are. It's a different meeting ID.
Is that what it's called? ID?
I don't know, key or something or ID. It depends which website you're looking on.
And
It's just a
centered-
different meeting that you set up. You can set them up to recur.
Yeah,
Okay, but this is our Monday morning Astro Hour
yes, that's right.
ID or meeting or whatever. And they all cost the same. And we used to have one for the meetings, the general meetings from the museum, that Tom Totten would stream it for people like Tim that doesn't show up. So that's gone. Do we still pay on it, or are we using it, or?
The museum
what I'm
does that one. Sometimes we
Tom-
do it, sometimes the museum does it. It depends where we're doing it.
Okay, so we're using there, and the word is ID. Each of
Well,
us has
no,
a-
it's meeting ID, really. I mean, it's just a different meeting that's scheduled on your Zoom account.
Yeah.
And there's a museum Zoom account and there's our Zoom account.
Okay, we have one account,
Yeah.
and we could hold up to how many pictures on screen, how many people could sign up, how many of these could you send out on email links?
It's tons, I think.
Tons of them, really? Have you ever found yourself among 400
Oh, yeah.
pictures on the screen?
Oh, not 400, but 30 or so.
Wonder if there's a maximum.
There is. There's also a maximum that your bandwidth will support, and you'll start to get flaky results.
Oh, is that why?
Yeah, this is pretty good, showing the caps shrinking and
Yeah.
growing.
And this is the CO2 part.
Yeah.
The leftover part, the white stuff, when it goes down to minimum, that's mostly water ice. So this is the North Pole on the left and the right pole on the other side. And these are combinations of photographs and enhanced drawings so you can see the pick it out easy.
I thought this was an enlarged view of your computers freezing up.
Right now it is.
And the thing about the water ice there on the left, that's the South Pole actually on the left, is that it's hard to discern here, but it's kind of layered. What happens is when the CO2 goes and puffs up the atmosphere and gets the dust clouds, you can get red dust that comes and covers some of the ice.
Yeah.
And then the stuff refreezes on top of it. There is some amount of water vapor that can be in the atmosphere and then refreeze on it. And so you get a layered cake kind of structure. Strata.
Oh, okay.
Right.
But we don't have a similar phenomenon like this going on the Earth, do we? Thank God.
Well, we have the polar ice.
Yeah. We have a lot more water ice, obviously, than
We're having
Mars does, but we have massive ice. So this does happen to our poles. You hear about recently with global warming that the North Pole region is almost navigable all year long because the North Polar cap shrinks so much. So it does grow and shrink with seasons. You don't notice it so much on Antarctica because it's got such a mass of ice.
Well,
Plus,
there's a
the
whole
warming is more concentrated in the northern hemisphere.
Yeah.
There's a whole new ocean up there, isn't there?
That's what everybody's jockeying for.
I know. Us and Russia on opposite sides of it. Right across the pond is the enemy.
Well, that's Canada's ice.
Well,
Yeah.
that's true. Well, hopefully they're with us.
Yeah, well, we're trying to piss them off.
I think we're doing a good job of it.
Yeah.
Oh yeah.
But of all this carbon problem we're having with global warming, it never forms itself as dry ice somewhere on the planet.
We don't get temperatures low enough for that.
Oh, it takes it.
Oh.
Okay,
Okay.
got it. We can make it low enough to rent it out to parties.
Yep.
All right. Fascinating.
This is a freeze frame of what you were just looking at.
Yeah.
And let's see if I can get.
Well,
Oh, yeah.
dry ice just adds carbon dioxide to the thin Martian atmosphere every year, doesn't it?
This is interesting.
Now these are streaks as it went by. Psyche went by. It took these pictures of these streaks, which may be frost. I think most likely it is. Oops, where's my? Oh, there it is. My cheat sheet.
It's not wind?
It's dust. Some of it is dust being blown too.
This is shows streaks that have formed due to wind blowing over impact craters in the Syrtis Major region.
So that's down more toward the equator.
Yeah. So this is not likely ice, I believe. I don't know. Interesting phenomena. And this is a color enhanced view of the large double ring Mars crater Huygens that's and the surrounding area. So the Psyche instruments look like they're all ready to go and easily capable of showing very interesting pictures of Psyche when it gets there. Now we have, as you can read in the
this is interesting.
in the newsletter, there is speculation that, but good reasoning, that there may be water ice, not water ice. There may be an ocean under Pluto's surface, and the reason that they think there might be water ice down there is because
Water.
Is what?
Water, not water ice. I think it's water.
Well, this is water ice, and this is liquid water.
Yeah.
So if you look at, depending on how these things formed, if Pluto was a water world and then it froze, the ice up above here occupies, it has to do something, it has to expand to freeze. And when it does that, it pushes on itself and it creates pressure ridges. And so there are no pressure ridges on Pluto. There are only expansion ridges on Pluto, which are crack features where it shrank in size as a once. Well, anyway, I'm going to get myself in trouble with that.
Yeah, I think you got it just the opposite.
Yeah, that's what I started to sense.
Yeah.
So anyway, based on the shape of the pressure ridges or expansion ridges, because recall when New Horizons went by Pluto, they took a lot of really detailed pictures of the surface. And based on the surface features they see, the type of ridges, expansion or contraction, they've decided that Pluto has no, it was always had a liquid core. It was always frozen. But it has a source of heat. And the source of heat is the fact that it has a moon, Charon, out here, and they're close enough that this one is getting tidal friction inside, and with the radioactive elements in it that it must have, it's calculated to be enough heat so that liquid water exists inside an icy shell.
Wow.
And this is a close-up view of each of the two of them.
So
It's just at that distance, it's just so hard to believe that it could still be liquid.
32 degrees.
Well, it's not liquid on the surface.
Right.
And you
Yeah.
have radioactive elements decaying and heating it from the interior, plus this flexing going on.
Yeah.
Yeah.
So the math, the thermodynamics, which is not that difficult to do, comes out to the fact that it's got to have liquid water inside. And
Huh.
as you'll read in the newsletter, we also have Europa, where the people that decided that the geysers that we saw geysers of water coming through cracks on Europa, and therefore Europa must have an ocean in it too.
Yeah.
They're retracting that conclusion a little bit because they're going back and redoing their data. And what they decided were visible plumes coming out, they think now is noise in their data. It's processing noise. So,
Really?
But it still has a subsurface ocean. It just doesn't have the geysers.
right. And so they've reduced their geyser conclusion from a 99% certainty to less than 90% certainty. So, and that is the way science works. So,
But since you're dealing with tidal friction, it might be warm water or even hot water down there.
Right. They could have geothermal vents like we have at the bottom
yes.
of our oceans.
And this is a close-up photograph of what has been determined to be an ice volcano on Pluto.
An ice volcano.
So something is warm down there that causes the ice at the point of it being a liquid or a solid to force itself out of the surface through cracks. And so this is evidence that there is a heat source inside, and there's most likely water inside Pluto.
A comment from the live chat is that it's too bad that the New Horizons didn't have a magnetometer.
Yeah.
What's that?
What would that do, Jerry?
Magnetometer would measure its magnetic field.
Oh, okay.
Which would tell you if it has a hot liquid core of metallic substances.
Right.
Okay.
Now, the New Horizons spacecraft was an interesting history because I was working on spacecraft at Santa Barbara Research Center when the contract came out for this guy at JPL, and it was an impossible short time frame. They wanted it. They had extra money. That's news for NASA. And they gave this guy, can you get something ready for Pluto? And we wanted very high, very low risk. Now, low risk in satellite means no intricate mechanisms. So he had parts of other satellites and he kludged together and had parts made to get them all together, but there was no aiming or pointing mechanism that could freeze up or anything. So everything was fixed to the main bus for the probe. And so to change your angle of view, you have to actually move the satellite and repoint the whole satellite.
Ooh.
Gimbal the camera out, which is a very low risk. Risk mechanisms, intricate mechanisms means risk. So if you want low risk, you don't have any intricate mechanisms. He put together this thing, put together a team, and he put it together in very short order. He was a brilliant engineer. He knew what he was doing, and this thing worked like a charm.
Huh.
He took advantage of this very short window with low funding, but enough.
How would they move? How could they gimbal the entire satellite?
It has reaction wheels on it.
Oh, okay.
They push against their angular momentum. And in some cases, for large changes, they'll have hydrogen peroxide jets on it. So,
but we're looking at the surface of Pluto there.
Yes.
This is the surface of Pluto.
Okay. And does it have an atmosphere?
Yes.
Sometimes it does. Sometimes it doesn't.
Whoa.
It depends.
Where does it go?
It freezes and snows onto the surface.
Yeah. And then when it gets closer to the sun, the atmosphere melts and sublimes back into the air.
And actually, they were surprised that they had as much atmosphere as they did see, given how far away it is.
Yeah.
Well, did I hear that Charon, the little satellite, also has an atmosphere?
I don't recall that.
I thought they both did for some reason.
Certainly got a lot of features here.
I heard
stuff. You see that reddish on the top?
Yeah.
That seems to travel along flex. That might be why somebody mentioned the magnetometer, because that seems to travel along flux tubes to land on the poles. Much like you have the auroras on Io and things ions being moved around.
But the big heart-shaped white spot on Pluto is nitrogen, I heard.
Nitrogen ice.
This is solidified nitrogen.
Okay, well,
And
that's not
it's got
exactly
no
water.
features in it. It's got no craters. And so it's relatively recent. The liquid inside might be water, it might be liquid air, it might be liquid nitrogen. Nitrogen forms a very nice liquid along with nitrogen. If you, like we did at UCLA, we got some liquid air as a cheap source of liquid nitrogen, and it actually looks sky blue when you look at it. Liquid nitrogen is clear, liquid air is sky blue.
But there's no nitrogen in H2O, I tell you.
That distant orb, whatever that is that a moon or is that the same?
That's Charon. That's its moon.
Yeah.
Biggest
that looks like somebody grabbed the top and bottom and kind of twisted.
Yeah.
Yep.
Now, this is another Pluto moon. This is Kerberos.
A little dumbbell satellite.
It's suggestive of that, like it's one of these hot potato things.
Contact binary.
Asteroid belt. Like it's stuck together. But the New Horizons didn't get close enough to get a real high resolution part.
It turns out a lot of these distant trans-Neptunian objects are binary structure, bilobe structure like that, because they're moving at slow speeds relative to each other and they can merge rather than having a catastrophic collision where they melt and turn into a sphere.
Shatter each other.
They just stick together.
So the conclusion of the article discussed the possibility of a liquid core for Pluto was generalizing that because of the heat sources and the surprise that there is a liquid core, most likely, they're speculating that liquid cores to Kepler objects that are big enough is general. They might all have them.
Kuiper belt objects, yes.
What's that?
Kuiper belt objects.
Yeah, what did I say?
You said Kepler.
Oh, good. Sorry, Kuiper belt objects, yes.
I didn't even know the name with Kerberos is up on the top there. I didn't even know that name of that moon.
By next week, you'll have forgotten it again. Trust me.
That's the three-headed dog that was the guardian of.
That's right.
Hades.
Yeah.
But you're saying, Jerry, that the whole center is liquid. It's a solid ocean without a big rocky sphere in the middle of it at all?
No.
You're not saying that.
There's somewhere inside there's an ocean.
Yeah.
Of something.
Okay, but oceans are only so deep and then they hit rock, don't they? Or something, I would think.
They may.
They may or may not. Is it?
Yeah.
You imagine a planet or a satellite even made totally of water?
Could be.
Oh, wow.
They may start that way.
Do they?
Yeah.
Okay.
Just ask Kevin Costner.
Yeah.
Well, they've got to start accepting.
So, one final thing I was an avid science fiction reader in the 50s and 60s when I was a teenager. And I read a story about the first manned mission to Pluto. And as you know, Pluto was covered with solid nitrogen and possibly also solid oxygen and solid hydrogen. And so they go to it and they're going to land on it, and they're using Elon Musk's reverse rocket thrust to land, which in those days they didn't know that was impossible. So it's not. But they were going down, and their rocket exhaust hit a mountain of oxygen and a mountain of hydrogen, and the whole planet blew up.
Okay. Sounds like an episode of Twilight Zone we missed, but doggone. Yeah. Well, gentlemen, there were only 4 of us, but we had plenty to say, didn't we? A lot to talk about. We're going to see everybody again next week, or at least they'll see us on screen.
Yeah.
Monday morning Zoom program on YouTube called the Astronomical Units SBAU Astro Hour. Till then, Chuck, you want to do the
Asta Nebula.
There you go,
Happy
everybody.
Happy Memorial Day.
That's
Yeah,
right.
yeah. Happy
Thank
Memorial.
you.